There is a train running through the mountains of North Wales that should not exist, not because it is dangerous or experimental or forgotten by history, but because everything about it belongs to another era. The valves, the boiler, the way it moves, every operating principle at work inside that locomotive was locked down before the American Civil War ended, before the telephone existed, before electric light was even a laboratory curiosity. And yet, on any given morning in 2024, you can buy a ticket, walk to the platform at Porthmadog Station, and watch it arrive in a cloud of steam that would have looked completely familiar to a passenger standing on that same platform in 1879. This is not a museum piece. It is not a heritage novelty operating on weekends for tourists who want a photograph. Now, the Ffestiniog Railway has been running continuously, almost without interruption, since 1836. That makes it the oldest surviving railway company, still operating its original route on Earth. But the age of the railway itself is almost secondary to what it runs, because the locomotive design that became the Ffestiniog signature, the machine that defines what this railway is, came from the mind of a man who was absolutely certain he had solved the future of rail transport. He was wrong about that, and right about it simultaneously, in a way that took 150 years to fully appreciate. His name was Robert Fairlie, and the locomotive he patented in 1864 was, by any reasonable engineering measure, a radical departure from everything the railway world had accepted as settled. To understand why, you have to understand the problem that Victorian railways could not solve. As train lengths grew, as cargo demands pushed upward, as gradients on mountain and narrow gauge lines became steeper, the conventional locomotive hit a wall. A single boiler, a single set of driving wheels, one fixed wheelbase. It worked beautifully on straight, level track. Put it on a sharp curve with a heavy load on a mountain grade, and the geometry fought you at every turn. Literally, the rigid wheelbase that gave a locomotive its tractive grip was the same thing that made it bind and slip on anything tighter than a gentle curve. Engineers had been patching at this problem for decades. Longer wheelbases, better suspension, flanged wheels with varying tolerances. All of it was compromise. All of it traded one problem for another. Fairlie did not compromise. He turned the entire concept inside out. What he built was, essentially, two locomotives sharing one boiler, or, more precisely, one massive boiler sitting above two independent power bogies, each of which could swivel freely beneath the chassis. Each bogie had its own cylinders, its own driving wheels, its own valve gear. The boiler fed both. The fireman worked from the center, flanked by equipment on both ends. The locomotive could enter a curve, and both bogies would articulate independently, keeping every driving wheel in firm contact with the rail. No binding, no slipping, maximum adhesion through the full curve. The weight distribution was extraordinary for the era, because the boiler sat centrally over both bogies, rather than forward over a leading axle. Fairlie could put vastly more of the locomotive's total weight onto driving wheels. On a conventional engine of the period, a significant portion of the weight rode on unpowered carrying wheels, necessary for stability, but contributing nothing to traction. The Fairlie eliminated that dead weight. Everything pushed, everything gripped. On paper, it was brilliant. In practice, the first full Fairlie locomotives built for the Ffestiniog Railway, delivered in 1869 and named with Victorian confidence, little wonder, exceeded every expectation the railway's engineers had dared to publish. Comparative trials were run. The results were not close. Little wonder hauled loads that had previously required two conventional locomotives, around curves that would have caused those same locomotives to slip and stall. The numbers circulated through the railway engineering press and reached audiences from London to St. Petersburg to Mexico City. Fairlie became, briefly, one of the most celebrated locomotive designers in the world. What happened next reveals something uncomfortable about how the railway industry actually worked, then and arguably now. Fairlie spent years lobbying the major railway companies of Britain to adopt his design. He published, he lectured, he arranged demonstration runs. He brought engineers from Russia, from Prussia, from New Zealand to Wales, to see Little Wonder in operation. And they came. They watched. They measured. Many of them went home and built Fairlie locomotives of their own. But the major British railways, the Great Western, the Midland, the London and North Western, did not follow, and the reasons were partly technical and partly institutional. The double boiler arrangement was genuinely more complex to maintain than a conventional engine. The central cab position, while logically sound, took some adjustment for crews used to traditional layouts. The fireman, working between two fireboxes rather than at a conventional rear position, required a specific technique that took time to develop. But beyond the technical friction was something harder to overcome. The big railways had infrastructure, workforces, spare parts, and institutional knowledge built entirely around conventional designs. Changing that meant not just buying different locomotives, it meant retraining, retooling, rethinking supply chains. The standard locomotive was deeply embedded. Fairlie was asking for a revolution at a moment when the industry's appetite for disruption had its limits, so the Fairlie design found its home at the margins, in Mexico, where mountain railways desperately needed traction on steep, winding grades, in Russia, in New Zealand, on colonial lines in India, where the terrain demanded articulation that conventional designs could not provide, and most durably, on the narrow gauge lines of Wales, where the Ffestiniog Railway had the grades, the curves, and the management culture to recognize that Fairlie had genuinely solved something. The Ffestiniog built more Fairlie locomotives, named them, operated them year after year. When the railway faced its darkest period, a nearly complete shutdown that lasted from 1946 to 1954, and when the tracks disappeared under mud and volunteers spent years digging them back out by hand, the ferries survived. When service resumed, they went back to work. Today, two double Fairlie locomotives operate on the Ffestiniog. Merdyn Emrys, built in 1879, was extensively rebuilt in the 20th century, but has been working this line for over 140 years. Earl of Merioneth carries passengers through Snowdonia on a boiler and running gear that embodies principles Fairlie had worked out before Edison filed his first patent. Stand at Tarney Bulch Station on a clear morning and watch one of them climb toward you out of the valley. The exhaust beats are unusual. 2 cylinders from the front bogie, 2 from the rear, alternating in a rhythm that sounds different from any conventional locomotive. The machine moves with a fluidity around the tight curves that larger, more celebrated engines cannot match. The whole apparatus is articulating, flexing, gripping, doing exactly what Fairlie designed it to do in 1864. The question that lingers is why this story is not better known. Why Robert Fairlie does not sit in the popular imagination alongside Brunel or Stevenson. Why the Double Fairlie is not cited in engineering textbooks as frequently as it perhaps deserves. Part of the answer is geography. The Ffestiniog Railway runs through spectacularly beautiful but deliberately remote country. Narrow gauge, by definition, serves the margins, the places standard gauge could not reach and did not bother to serve. Victory at the margins is still victory, but it does not generate the press coverage of a mainline record run. Part of the answer is the failure to penetrate the British main line. If even one of the major railways had adopted the Fairlie design in the 1870s, history would remember it entirely differently. But they did not, and the institutional story of British railway engineering was written by the companies that survived, expanded, and generated the archival record that historians later excavated. And part of the answer, if we are honest, is that Fairlie himself was not skilled at the politics of persuasion in the way that the era's successful innovators tended to be. He had the data, he had the demonstrations. What he lacked was the network, the institutional backing, the well-placed advocates in the right boardrooms at the right moment. The machine outlasted the man. Fairlie died in 1885, having seen his design spread to dozens of railways on multiple continents, but having failed to achieve the transformation of mainstream British practice he had intended. The locomotives kept running without him. In 2024, that is still true. The Ffestiniog carries hundreds of thousands of passengers each year through one of the most dramatic landscapes in Britain. The Double Fairlie locomotives, Victorian engineering operating in a world of digital signaling and GPS navigation, are not running in spite of their age. They are running because the design was correct. The articulation principle that Fairlie worked out in his drawings in the 1860s is not a historical curiosity, though it is the foundation of how modern articulated locomotives and multiple unit trains manage the same problem he identified 160 years ago. The terminology changed, the fuel changed, the scale changed enormously, but the central insight that a locomotive's wheelbase must be able to negotiate curves while maintaining maximum adhesion remains as valid on a modern high-speed line as it was on a Welsh narrow-gauge mountain railway in the 1870s, which raises the question worth sitting with. How many other designs from that era were correct and simply lost because they appeared in the wrong place at the wrong time, championed by the wrong person, without the institutional weight to force their way into the mainstream record? The Ffestiniog does not answer that question, but on a clear morning in Wales, in watching a locomotive that was designed before the telephone existed haul its passengers through the mountains without visible effort, it makes the question feel genuinely urgent. Some things endure because they are celebrated. Some things endure because they simply work too well to stop.